So in this example here, we have this compound statement here. It is not true that a cheetah is a fast land animal and a tortoise is a slow land animal. So what we need to do is we're going to write a statement that's different than this, but still logically equivalent. So as we look at this statement here, it is not true that a cheetah is a fast land animal and a tortoise is a slow land animal. So you could probably see that this is P right here. A cheetah is a fast land animal. So I'm just going to put in P. And we have our and. Here's our and. And then a tortoise is a slow land animal. So this is probably our Q. But you can see right here we have this it is not true right here. So this probably looks like this. It is not true, P and Q. So we're going to write a statement that's logically equivalent to this statement, except we're going to use De Morgan's laws to do that. And De Morgan's laws make it very convenient to be able to write those statements that way. And what De Morgan's laws states is that if you have a statement that is, it is not true, P and Q, that's logically equivalent to a statement that's not P or not Q. So then to write a similar statement like this that's logically equivalent to it here, I'm just going to write down a cheetah is not a fast land animal, or a tortoise is not a slow land animal. So this statement is logically equivalent to this one. It is not true that a cheetah is a fast land animal and a tortoise is a slow land animal. That's logically equivalent to a cheetah is not a fast land animal or a tortoise is not a slow land animal. You know, another way that we can write this, how about if we say a cheetah is a slow land animal? So can't we interpret that not fast means slow, right? Or a tortoise is not a slow, so we can say a fast. Because I guess we can interpret not slow as being fast, but that's another way. This next example here, same idea. We have Hannah is not going to the homecoming dance, and she is not going to the homecoming game. So maybe you can see right here, Hannah is not going to the homecoming dance. Maybe this is not P. We have an and then we've got a not Q. She is not going, Hannah is not going to the homecoming game. So maybe that's not Q. Again, we're going to write a logically equivalent statement, same as this one. And again, we're going to use De Morgan's laws. De Morgan's laws also says that it is not true, P or Q is logically equivalent to not P and not Q. So a statement that is logically equivalent to this can be written as it is not true that Hannah is going to the homecoming dance or the homecoming game. So it is not true that Hannah is going to the homecoming dance or to the homecoming game. is logically equivalent to Hannah is not going to the homecoming dance and she is not going to the homecoming game. So to show that why these statements are logically equivalent to each other, we'll go ahead and we'll make their truth tables. So I'm going to do that. So we'll go ahead and we'll list the simple statements here, P and Q. True, true, false, false. Hopefully by this time in the chapter you know how to do this. You can see that I have not P and not Q, so I'm going to put those in. That's just a personal preference. You're going to need them anyways. Those are the negations. Now for this one up here, I'm going to put in it is not true, P and Q, and I'm going to do it all at once. It is not true, P and Q. Now inside the parentheses here, this is a conjunction, P and Q. Both simple statements must be true for the whole thing to be true. That occurs right here. So it's going to be true, false, false, false. But then we negate it. So it actually comes out to be false, true, true, and then true. I'll then do not P or not Q. This is a disjunction. For this disjunction to be false, both simple statements must be false. And that occurs right here. So this is false. Other than that, it's true. And as you can see, they're logically equivalent to each other. Their truth values match up, so they're logically equivalent. We'll do the same for this one. It is not true, P or Q. Again, this is a disjunction. For this disjunction to be false, the simple statements must both be false. That happens down here. So this would be true, 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 false, but we negate it, so it winds up being false, 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 and then true. We'll then do not P and not Q. This is a conjunction. Not P has to be true, and not Q has to be true for the entire compound statement to be true. That happens right down here. Here it is true. Other than that, it's going to be false. And of course, as you can see, this right here, these truth values match up with these here. So these two are logically equivalent.